Thermodynamics is the study of the relationship between heat, energy, and work. It is a branch of physics that deals with the principles governing the behavior of matter at the macroscopic level. The subject is vast and can be quite complex, but I will do my best to explain it in simple terms. Thermodynamics is based on a few fundamental concepts, which are the laws of thermodynamics. These laws govern the behavior of all thermodynamic systems, which include everything from a cup of coffee to a steam engine to the entire universe. The first law of thermodynamics states that energy cannot be created or destroyed, only transferred or converted from one form to another. This law is also known as the law of conservation of energy. It means that the total energy of a closed system remains constant, and any energy that enters or leaves the system must be accounted for. For example, if you heat up a pot of water on a stove, the energy you put into the system, in the form of heat, will be transferred to the water, and the water will heat up. The total energy in the system, water plus stove, remains constant, but the energy is converted from one form, heat in the stove, to another, heat in the water. The second law of thermodynamics states that the total entropy of a closed system will always increase over time. Entropy is a measure of the disorder or randomness of a system. This law is also known as the law of entropy. In simple terms, this means that over time, everything in the universe will become more disordered and less organized. For example, a cup of hot coffee will eventually cool down as heat energy is transferred to the environment. The once organized and concentrated energy of the coffee will become more dispersed and disordered as it spreads out into the environment. This process is irreversible, and energy will never spontaneously flow from a cold object to a hot one. The third law of thermodynamics states that as the temperature of a system approaches absolute zero, the entropy of the system approaches a minimum value. Absolute zero is the temperature at which all molecular motion stops. This law is also known as the law of absolute zero. In simple terms, this law means that as you approach absolute zero, the randomness and disorder of a system decrease until it reaches a minimum value. This law has important implications for the behavior of matter at extremely low temperatures. Thermodynamics can be applied to many different fields, including chemistry, engineering, and physics. One common application is in the design and operation of power plants. Power plants use the principles of thermodynamics to convert heat energy into electrical energy. For example, a coal-fired power plant burns coal to heat up water and create steam. The steam then drives a turbine, which generates electricity. The principles of thermodynamics are used to design the power plant so that it is as efficient as possible and wastes as little energy as possible. Another common application of thermodynamics is in the design of refrigeration systems. Refrigeration systems use the principles of thermodynamics to transfer heat energy from one place to another, such as from inside a refrigerator to the outside environment. Thermodynamics can also be used to explain many natural phenomena. For example, the greenhouse effect, which is responsible for keeping the Earth warm enough to support life, is a thermodynamic phenomenon. The Earth's atmosphere traps heat energy from the sun and prevents it from escaping into space. This is similar to the way a greenhouse traps heat energy inside. Without the greenhouse effect, the Earth would be too cold to support life. In conclusion, thermodynamics is the study of the behavior of matter and energy at the macroscopic level. It is based on the laws of thermodynamics, which govern the behavior of all thermodynamic systems.